Welcome to today's episode of the Cross Labs podcast, On My Mind. So for today's On My Mind episode, we have 8 possible topics. We have 6 people in person. We also have 2 people virtual. And we're going to pick the topic right now as opposed to doing it before. I'm going to ask ChatGPT to pick a number between 1 and 8. My choice is 5.
Only 5, okay.
All right. So today's topic is, what if we built computers out of people on social media or proteins? Or is there free computational work being done somewhere in the world in such a way that we can use it? So in other words, can we assume every non-random dynamical system is a computer only if we configure it in some particular way? Discuss.
I actually don't think there is any way that we could demonstrate that we are not that someone's computer. Like, I don't know, the bus that we take, it's literally like the bus on a GPU connected to a CPU somewhere.
I feel like this has somehow jumped from the question of using physical people as a computer versus people being simulated. You could see if you're part of a computer because all you have to do is see whether or not there's external inputs.
But what if you can't see the external inputs? And it's not just people either. It's like anything, any non-random physical process.
Well, that's what I mean. That in order for it to be used as a computer, there has to be a way to reliably put in inputs and extract outputs. So if you can vary the surface of the system and change what actually information can flow in and out, you may not be able to prove whether or not you're being used as a computer, but you can definitely break your function as a computer for someone else. You can disrupt whoever is trying to use you for computation.
If you knew what the inputs and outputs were, right?
No, I mean, you just isolate yourself from all inputs and outputs, right? I mean, the most extreme thing is you just die. But like, less extreme than that, of course, is you go into a sensory deprivation chamber, you detach from social media. You have an input surface, which is something that you actually have agency over. This does not prevent people from being usable as computers. This just, I guess, gets to Aneris's question of like, to what degree would you have any kind of power over whether or not you're used as a computer? The thing is, you do have power over whether or not you're used as a computer, but the exercise of that power is personally costly.
So I guess that's another question is like, how do you make your computation such that you don't have it detectable to users?
Well, I mean, if you want to do a computation, then the outputs have to be dependent on the inputs, right? So whatever it is that you are measuring, which might be something that a person is carrying with them, but if it's actually the person's behavior, that means that there will be an observable that is relevant to person scale that someone could use to figure out, hey, there's something like statistically weird going on here. Now, if you didn't actually want to use like a person's decisions as the output, but you use something like, I don't know, their blood sugar level or something like that, then yeah, you might be able to get away with a signal that is not perceptible to the host of the actual computational unit, which would be basically their blood in that case. So you can have one thing where you're using the person at the abstraction level of a person as the input-output system, and then, like Luke is mentioning, do reservoir computing kind of things. And that wouldn't necessarily be something that people would just notice, even if it was changing their behavior. But it's something that if someone wanted to look for it, I think it could be detected, because it has to change their behavior.
If we consider the universe as a Bayesian network, causal Bayesian network for a moment, or some kind of CA, then they would have to basically intervene in order to put an input, so they would have to kind of break the causality of the universe or whatever. Like the universe wouldn't be causally closed anymore.
Well, I mean, like you're also talking about as if there's something outside the universe, but like literally if this was Google trying to use you to do computation, of course they're enmeshed in the causality of the universe. And if you actually traced the flow of that influence, you would notice it flowing through things that it shouldn't, right? Like your model of the causality of the actors would indicate that there's this flow that's going in this kind of weird way that would indicate that you're missing something, which is that Google is intentionally regulate the system to perform a computation.
Or whoever.
Yeah. It could be OpenAI, it could be Microsoft, it could be Apple. Let's get sued by everyone.
Cross that. Open-minded. We wouldn't be. It's such a thing. We promise.
One example of using people as a computer, I mean, not exactly a computer, but using people as a generator of data, of information, is things like A/B testing. If you're participating in A/B testing, you might not know that you're participating in A/B testing, and you wouldn't automatically find out. But also at the same time, the things that are being manipulated, the intervention that they're doing isn't really meaningful to you for the most part. So while there is something about your environment that's being intervened on, it's also part of your environment that you leave open to be intervened on because you're literally intentionally accessing an external source of information when you go browse a website.
Is there a way for you to tell for sure that there is someone doing A/B testing if they're not, they're trying to hide it?
Yeah, you have a secondary IP, browse the same site, and then you compare.
Is there a way to take that idea and turn it into a massive computer somehow?
I feel like the answer is evidently yes, but how much, given a sort of, cognitive system that is in more than one agent or just the whole thing, how much compute can you steal from the system before it gets noticed? Video games are using some of the users for certain recognition tasks and things like that, right?
Well, it captures.
Yeah, captures. Yeah.
It's very noticeable, and it does piss people off. So captures are evidently above threshold.
Right.
I have a question. So let's imagine that I live in a country where there is a public national broadcaster that broadcasts, of course, information, and this is funded by the public but controlled by a very specific group of people. And then they feed very specific information. So then the party that gets into power, since this artificial entity exists, is literally the same. But we all think, well, I don't vote, but the people all think that they had their own will to choose whoever is in power. And that's something that differentiates them from other countries in the vicinity that have a single party elections. But I mean, in this particular place, they have multiple parties, but the same one wins all the time. So it's basically a single party democracy. Wouldn't that count as giving the exact input to get the output I prefer? So that would be a computing mechanism, wouldn't it be?
No, I wouldn't actually call that compute. That's manipulation, but not compute.
What would be the difference there?
Well, so with compute, you want an output that you don't know what the output is until you get it.
Okay, yeah. Okay.
Right, you want to get information, you have the information in order to get that output, but there's a thermodynamic cost to actually converting it into the format that you can use. And so the computer pays the thermodynamic cost, then implements the transform. But if you want to fix the output, and you're trying to find the input, that's a different thing.
I also remember yesterday I was talking with Joe about, how in the US they have a massive amount of eggs for when they have the different types of flu and stuff. Wouldn't that be some sort of computation as well? When you don't know the output, you just get the input. The input is this virus that we know it's going to be dominant virus, and then we just compute over it on eggs, on single cells, until we get a not so strong thing almost dead that we can put in people and it's safe.
So the reservoir of eggs, it costs work to maintain, to keep a bunch of eggs. Right. So you're obviously putting work into the system to maintain some sort of state such that you can do a computational task of engineering a vaccine based on some dominant strain of a virus. It has to do with energy cost, I assume, right? Because computation takes work. As Nick was saying before, the computer is what's doing the thermodynamic work to transform one state into another state. So I would think that it would have to do with some sort of thermodynamic process for sure. Supposing the opposite of that, it's not taking work and it's just dissipating heat into the environment. Or, with the opposite of doing work, what is that?
Let me ask ChatGPT.
There is this whole reversible computation stuff, which is non-dissipative computation. I think that there is a limit. There's a practical limit, like the construction even though you're not burning bits, you're not producing heat, you are producing waste in the sense that you have to have a scratch space. And in some sense, as you progress down the computation, the scratch space gets more used.
Yeah, so comparatively in a human society way, you're paying much more because you have to get rid of those drives and get new ones.
Yeah.
It's terrible compared to the heat you would be paying, but yeah, sure. Yeah, why not?
Okay, then it's over, no? This whole thing.
This whole thing is over, Martin. This whole thing is over.
Yeah, it's finally over. Yeah.
This whole thing is over. Let's use this. What is this?
We'll dig over.
That's it for this week's episode of the Cross Labs podcast On My Mind. Don't forget to like and subscribe so you'll be the first to know when the next episode is out. Thanks so much for tuning in, and we'll see you next week.